It's important to understand the organizational hierarchy when you're going to look at a deployment inside of Azure. And similar to other CSPs, there's multiple components that can subdivide an organization's footprint. But at the top layer, everything starts with an AD tenant. That is the top organizational unit, and then that can then be subdivided into individual subscriptions. Some organizations may have a subscription per business unit. Some actually may even get more granular than that and do a subscription per application. But those subscriptions can be orchestrated however the organization sees fit. There's several different models for how those are consumed, whether it's a trial subscription, pay as you go, or some integrations in with M365. Now, inside of a subscription, we have another organizational construct called a resource group. And a resource group is a way to organize the individual resources within Azure and then apply. They can be done, again, through whatever mechanism an organization wants to divide those, but they can be used for billing constructs. They can be used purely for just organizing and making things easier, but they also have some RBAC implications as well. Then, of course, the bottom level is the actual resources themselves. There's another component called a management group, which could also be leveraged that helps with, again, with organizing some RBAC controls at more of that higher level for collecting or setting a pattern for all the subscriptions. When we look into the actual Azure services and resources, similar to how those are laid out in other service providers, they're broken down into list of resources, which are then grouped into different types of services before getting into the actual resource itself. So as you go into the Azure portal, there's a way to begin to list all of the services, and those are then generalized into categories like networking or compute or storage. Then within each of those categories, we have the basic building blocks or components that Azure natively offers. So you'll see, if we were to highlight compute as an example, you'll see things like availability sets or container instances, things like that. And then once we actually have things deployed, we can start to show all of those resources based on the type or category of resource that it is. So for instance, if we want to list all of our virtual machines, it's very easy to do so. Some of the important services as compared to some of the other CSPs. So the service name of a VM just maps to any virtual machine instance that's running. Azure Active Directory, very similar to what Active Directory was in the on-prem world. Now it's just up in the cloud, but that's primarily used in Azure for identity and access management. A VNet is just a virtual network, so that's synonymous with in AWS like a VPC or a VCN in Oracle. Then we have storage accounts, which often are leveraged by VMs, and there are different flavors of storage account. Most common ones are probably blob storage accounts, but there are others like files and queues and tables. Then ExpressRoute is the private connectivity mechanism from on-prem into the cloud. So again, that's synonymous with Direct Connect in AWS or Fast Connect in OCI. And then Azure DNS. Azure DNS is the global DNS service provided by Azure, which can be used. There's some integration in with on-prem, or it's a standalone service that can be leveraged in Azure by itself. Everything starts with a region in Azure. So as customers go to deploy, you select regions. Azure has multiple regions around the globe. But then within those regions, a customer will start to launch virtual networks or VNets. So a VNet is just a private container, isolated island that will inevitably host some sort of resources. VNet has one or many CIDR addresses that are associated to it. And then those VNets can be further subdivided into subnets. Now, a key component in virtual networks and subnets is that both are a regional construct, which means if the region supports availability zones, those virtual networks and subnets will span those availability zones by default. So we do not have to, as opposed to some other CSPs, we do not have to assign a subnet to a specific resource group. To a specific availability zone. Then our resources that we want to deploy, whether those are load balancers or virtual machines, will get deployed and assigned to a specific subnet, where they will then pull an IP address from that subnet itself. From a security perspective, one of the most common basic constructs is something called a network security group. The easiest way to think of that is a 5-tuple ACL that can be applied either at the subnet level or the NIC level of a virtual machine. There is also something called an application security group, which allows us to group like-minded resources and create policies based on that. So as an example, if we had a bunch of virtual machines that were all web servers, we could group them together in an ASG, again, application security group, and build those same five-tuple rule sets, but based on a common name like web servers. For basic VNet to VNet communication, Azure provides something called VNet peering. So VNet peering is a one-to-one mapping from one VNet to another. And when VNet peering is established, the VNet CIDR or CIDRs from VNet 1 are shared with the VNet CIDR or CIDRs from VNet 2. Some of the basic networking components. So we've already covered the virtual network. Again, that's that isolated pod that you can start to instantiate resources. But then from a routing perspective, we have the ability to create routing tables and associate those with specific subnets. Inside of those routing tables, we'll have some of our default system routes. If we have some connectivity to on-prem, either via ExpressRoute or a site-to-site VPN tunnel, we may have some BGP routes that pop in there as well. In addition, we can create static routes called user-defined routes. We'll talk a little bit about what that looks like from an architectural perspective, but one example, and probably the most common of where user-defined routes are used, is if we want to service chain a next-gen firewall into all of the traffic flows. Another component similar to other clouds, Azure has the concept of availability zones, right? These are multiple zones within the same region that can be used for redundancy. Key difference, though, is in Azure, not all regions have availability zones. So you have to be very conscious as a customer when you're selecting your regions within Azure to see whether or not that region supports availability zones. We talked a bit about the network security group. Again, that's the 5-tuple ACLs that can be applied to either a subnet or a NIC on a virtual machine. And then we have the concept of virtual network gateways. Virtual network gateways are a special Azure component that allow for the termination of on-prem connectivity, whether that's ExpressRoute, which is that private circuit to on-prem, or a site-to-site VPN tunnel. There's different native limitations with each of these virtual network gateways, and the virtual network gateways themselves are a managed service by Azure. So the only thing that they're used for is for terminating either that site-to-site or ExpressRoute connection. They also have some other requirements about dedicated subnets that they have to live in and certain routing nuances on how they share routes or how those routes can be shared to and from Azure. There's also the concept of public and private IP addresses. Now, this is a little bit different than AWS as an example, where we have public and private subnets. Azure doesn't have that same concept. Any subnet could potentially be available to the public internet, and that can be done in a couple of different ways. One of those ways is just by giving the instance a public IP address, and by default, it has access to and from the internet. In addition, one other sort of nuance is that as VMs are spun up in Azure, if the system default routes remain in place, all VNets automatically have access out to the internet. There's a default NAT that happens that allows that traffic out. Obviously, for most customers, this is not the desired behavior, so steps are taken to block that, but it is something to be aware of. Then we talked a little bit about VNet peering. So that's our way to allow one VNet to communicate to another VNet where the CIDRs are just exchanged on a one-to-one basis. An NVA is another common component within Azure Networking. That stands for Network Virtual Appliance, and essentially is any third-party firewall or router or marketplace item that can be deployed inside of a VNet. So some common ones would be Palo Alto firewalls or Cisco CSRs. All are NVAs that can be deployed inside of Azure. All right, so let's talk a little bit more about Azure VNet peering. So as I mentioned, this is the way where one VNet is able to talk to another. It's a one-to-one mapping that allows VNets to be directly connected. However, the key thing to note is that a VNet by nature is not transitive. So if I have VNet 1, VNet peered with VNet 2, which is then VNet peered to VNet 3, 1 can talk to 2, 2 can talk to 3, but 1 cannot talk to 3 through 2. So what that means is that if VNet peering is going to be used as a transitive mechanism between all of our VNets, it requires a full mesh of VNet peers because a VNet cannot be transitive. So this becomes pretty hard at scale for a lot of customers because we have to manage all of these VNets. In addition, there's some other native limitations where we can't necessarily customize the CIDR ranges that are being advertised. By default, all the CIDRs associated with a particular VNet are advertised across a VNet peering. So we have to be very careful that we avoid IP address overlap. For peering that is across regions, that is available in Azure as well. It is called something different. It's called global VNet peering, and it has a little bit of a different price point to it. But all the other rules and caveats still apply. So when we talk about transit in Azure, right, obviously VNet peering is an option, but that can become difficult at scale because of all the full mesh and some of the lack of flexibility there. But it's by far the most important part of the cloud networks. We inevitably, at the end of the day, have to get our workloads to be able to communicate with each other or communicate with on-prem. So understanding what our transitive options are inside of the cloud is very, very important. The preferred mechanism is to use that transit VNet peering. However, we do have a couple of other different options. If ExpressRoute is in the picture in your topology, there are some ways that you can leverage that ExpressRoute circuit to provide VNet to VNet, or sometimes you'll hear spoke to spoke communication. And that is nice because it provides a little bit more of a dynamic connectivity. In addition to that, if we're in a hub and spoke model, then we can also leverage one of those NVAs and UDRs to route traffic across VNet peerings to a hub, and then route that traffic down to another VNet through that NVA appliance. So we have a couple of different options that have pros and cons of being able to provide that transit connectivity inside of Azure. So that first option that I mentioned, where we are leveraging ExpressRoute to provide that transit communication, this is a very, very common method for customers to start. It has some nice benefits where the VNet peering charges are not incurred when we have spoke VNet 1 talking to spoke VNet 2 through that ExpressRoute circuit. Now, a key thing to note here is it's not actually traversing all the way back to on-prem. So we're not incurring any kind of ExpressRoute charges, but we are taking a little bit longer of a path as opposed to direct VNet peering, but at the trade-off of not incurring some of those costs. And it's also more dynamic. So we don't have to mess with UDRs or anything like that. Now, the default behavior is that anything can talk to anything in that kind of strategy. So if that's not what we want to happen, or we want to be granular about which VNets are allowed to talk to which other VNets, then we may have to leverage this feature and take some additional steps to block that, or service chain and next-gen firewall into some of that path. So one of the components of the ExpressRoute circuit is something referred to as the MSEEs, or Microsoft Enterprise Edge routers. And what this mechanism does is actually leverage that router to provide this transitive communication. Now, this isn't something that most customers see or really ever see, but it is a way that you can provide this transitive communication in a bit more dynamic fashion. So if we look at what it sort of takes to make this happen, if we have a single region where we have two spoke VNets that are connected to the same hub VNet, so our standard hub and spoke sort of topology, and that hub VNet has a single ExpressRoute router, From on-prem, what we would do is advertise in either a default route or a summary route, which covers our entire CIDR range. And what that does is it actually attracts traffic down to the ExpressRoute routers when Spoke 1 is trying to talk to Spoke 2. Because that ExpressRoute router is able to see the specific networks rather than continue to follow that default or summary route, the traffic can then just be vectored straight back up to the other spoke. Now, again, while this does seem like, maybe a little bit more configuration, the reason why this is a very, very common deployment is that even though when Spoke 1 is talking to Spoke 2, it's having to traverse VNet peering, the underlying fabric recognizes this data flow and does not charge for the data flow across that VNet peering. It's essentially exempt. So that's why it's a really, really nice mechanism for a lot of customers. Now, the challenge is this: by advertising that default in or that summary in, all spokes would potentially now have a route to all other spokes. So when we look at things like segmentation or inspection, that becomes a bit more difficult and requires some manual steps that we have to do. Some other considerations: if you do have latency sensitive applications or flows, we are taking a little bit longer of a path here because we're vectoring down into those ExpressRoute routers. So that may be something to keep an eye on for single region or multi-region traffic. This method is not officially documented by Azure, but again, is the most common deployment that we see from a lot of customers. The challenge, though, is that we're just sort of taking advantage of some default routing that happens natively in that underlay. Now, those ExpressRoute routers are very multi-tenanted. There's a lot of customers who have private circuits that are connected to them, and they all may be using the same kind of method. So we run the risk of things like noisy neighbor. We have to be sort of conscious of, somebody who may be doing some pretty heavy flows and the shared nature of that ExpressRoute router where this transitive mechanism isn't necessarily preferred. This is why the product group in Azure really recommends that VNet to VNet pairing, because that is dedicated to you as a customer, and we don't have to worry about any of those nosy neighbor problems. Okay, the second option that we talked about was, again, using our hub and spoke environment, but this time, rather than hairpinning off of ExpressRoute routers, we're going to hairpin off an NVA that exists in our hub. So in this instance, we could have, again, the NVAs are any type of VM from the marketplace. So it could be a Palo Alto firewall, it could be a Cisco CSR. But essentially what we will do is build our standard VNet peers between our spokes and our hubs. But within our spokes, we will define manual UDRs that say in Spoke 1, if you're trying to go to Spoke 2, your next hop is that NVA. And then the NVA is responsible for the routing of getting you eventually to your destination. This can be a really nice mechanism for if you need to service chain some security in the path or do some traffic inspection or maybe even segmentation between different spokes. Now, it does come with some manual configuration, as the UDRs in those particular spokes have to be kept up to date. So as your environment continues to scale out, new spokes are added, we need to make sure that we are constantly updating the UDRs as our environment grows. And this is really where a lot of customers have some challenges, because that UDR management at scale becomes a bit cumbersome, and there's a high risk of user error when those are inputted. Another architectural choice, which for that customers often look at, is something called Azure Virtual WAN. So essentially, as customers were leveraging all of the native options that we just discussed, customers wanted networking to just be easier in Azure, right? Almost make that networking disappear, have things be a bit more automated, and not have to have any of the manual configuration components that are required. So Azure responded with something called Azure Virtual WAN. It was initially proposed in 2018, and the idea is it's built upon hub and spoke, but that hub becomes a managed service. So Azure takes care of the hub portion of this, and then you just just plug in your VNets or your on-prem sites into that hub, and the networking is automatically taken care of. So what that means is there's the ability for route redistribution automatically. There's an increased number of connections that are allowed, so we can have a larger number of branch sites or on-prem sites. There's also some ability to be transitive for on-prem to on-prem. So if we have branch needing to connect back to a data center, we could actually make that a little bit transitive within Virtual WAN as well. So Virtual WAN is a really good option for customers inside of Azure. Now, the Virtual WAN is not without its challenges. It's, again, a very good architecture inside of Azure, but we are living more and more in a multi-cloud world. And so that's really where Azure Virtual WAN starts to get a bit fractured, is when we talk about the multi-cloud angles. So the Azure Virtual WAN does a really good job of trying to centralize the control plane for customers and make that easy. But if that footprint starts to extend into other clouds, then Virtual WAN doesn't have any control plane connectivity into that other cloud. So that's where things start to get a bit fractured. In addition, the Azure Virtual WAN is a pretty large platform. There's a couple of different varieties, but for most customers, the choice tends to be an all or nothing approach. They either have to go all in on Virtual WAN and stay within the confines of Virtual WAN, or revert back to a hub and spoke type of environment. Now, the trade-off with any managed service is you tend to lose a little bit of control and a little bit of visibility. So inside of that Azure hub, that's the managed portion of Virtual WAN, there are only limited third-party devices that are approved to be in there. So our NVAs that we are used to putting in there, a lot of those NVAs are not supported in the hub. And so some of the traffic flows becomes a little bit difficult. The service chaining of those becomes a little bit more difficult and a little bit more manual. But also too, for some of we also lose a little bit of visibility and troubleshooting. So we don't have the same level of visibility into that hub that we would have if it were just a normal standalone hub. There are some native limitations. Azure is working on raising these and has been since 2018, but there are some limitations that customers also have to be aware of. When it comes to some of the advanced services for some real world scenarios, so we may have mergers and acquisitions or partner connectivity that's overlapping IPs, or we need to do some really granular segmentation. That's where some of those advanced services aren't yet in Virtual WAN. Again, Azure's doing its best to continue to add services, has done so as recently as the last Ignite, but there are still, customers often run into some advanced services that are a little bit lacking inside of Virtual WAN. If we look at sort of taking all of our pieces and putting them together in our traditional hub and spoke environment, then what we start to see is a little bit more of a flexible and repeatable pattern where we can put our VNets in that hub and spoke, have a couple of different options for transit as well as private connectivity, but it's a model that extends a little better especially as we start to talk about multi-cloud, which is a big component of the Aviatrix solution. Now, as you can see from this diagram, there's a lot of stitching that has to happen to make all of this work. When it comes to service chaining firewalls in the path or providing transitive connectivity for multiple spokes, as well as potentially looking at leveraging advanced services like Azure Paas services via private link or third-party services. And that's the piece where the customers tend to struggle a little bit at scale, is stitching all of these components together. Azure does a really good job of giving you the tools in the toolkit to be able to leverage what you need, but it's very much of a build it yourself kind of approach. So while we have a couple of different architectural examples natively with Azure in the standard hub and spoke and the Azure Virtual WAN, there's definitely trade-offs when it comes to customers looking at large-scale deployments. With that, we have some Azure video resources that are available in the links below. They go into a little bit more detail on a couple of these items. So feel free to check those out. But also, you can reach out to any of the Aviatrix solutions architects, and we're happy to discuss any of the native options